So HCV series continues electrostatic. Now here is the question. A ring of radius A contains a charge Q distributed uniformly over its length. Find the electric field intensity at a point on the axis of the ring at a distance x from the center. Say for example this is a ring, charge ring, and from its center at a point P you have to find out the electric field intensity. Right? This is the way. Now diagrammatically how we are going to represent. This is a diagram, charge ring, and this center radius is A. At the at a point P we have to find the electric field intensity. P is at x distance from the center of the ring, charge ring. The charge ring, right? So at this particular point, we have to find out the electric field intensity at point P. That expression we have to find out. So what we are going to see, we have to choose a particular point here, a small point charge having value dq. So from this particular charge, due to the dq charge, the electric field intensity is having this particular direction along dE. Let us consider its angle is theta. This theta, this also theta, vertically opposite angle. This theta, this dE is going to resolve into dE cos theta in this way, and another component, this dE sin theta. Similarly, if we are going to take the another charge just diametrically opposite here, the same thing happens here. We are going to take this angle theta, this theta, so that dE, and this dE is going to resolve into two components, another here dE cos theta, and here it is dE sin theta. So what we are going to observe, the vertical component are having this are acting on the same point, so these two are going to cancel. This also dE sin theta, these are going to cancel, leaving behind only this component, means axial component. So we have to write in this way. Here dE cos theta we have to find out, only this cos theta. So dE cos theta, how to find the dE? That is your k dq by that your AP square. AP square, that is the magnitude, into cos theta. We require dE cos theta only, because vertical component are going to cancel each other. So ultimately k means dq by 4 pi epsilon naught AP square. AP square we can write the a square plus x square, this AP square. In this writing a triangle, hypotenuse square is equal to b square plus p square, whole square is there. So here AP square is equal to this into cos theta. Cos of this theta means b by h. So we can write the x by h is your a square plus x square whole to the power half. Right? Clear? So it will become the 3 by 2. So now it will be, here it is, E net is equal to dq into x by 4 pi epsilon naught a square plus x square whole to the power 3 by 2. Right? So therefore total net electric field, this field is in fact due to the this one small dq. dq के चलते यहाँ पर फील्ड निकालें. अब टोटल निकालने के लिए वी आर गोइंग टू इंटीग्रेट. सो E is equal to integration of dE cos theta. That if you are going to integrate, we will get the x by 4 pi f naught a square plus x square whole to the power 3 by 2 into integration of dq is equal to x q by 4 pi f naught a square plus x square whole to the power 3 by 2 E total. That is the magnitude expression. And direction is the same. Direction is this. This is the direction. Along this direction, away from the axis or center, this should be the direction. Right? Another question, 3 charges each of q coulomb are placed at 3 corners of a square of side A. Find electric field intensity at the 4th corner. One square ABCD, q charge, q charge, q charge are the positive q q q. Here no charge is there. You have to find the electric field intensity at this particular point D. Right? So this is the one charge, this is the another charge, this is the third charge. So first of all, at this point, the electric field intensity is having this direction, and it's a value, say for example, that is your E1. And if you are talking about the charge at point A, the electric field intensity is this at this point is away from it, that is say the E2. And this particular charge is also there. From by this particular charge, the electric field intensity at point is D is along this. Say this angle, this E1, E2, and this is your E3. Now we have to find the resultant. So first E1. So how to find the resultant here? The 3 directions are there. First, we have to find the resultant of E2 and E3. That will be along the same line. And whatever the resultant of E2, E3 will be there, we are going to add E1 because this is also along the same direction. That will be the basic idea. So now to find, say for example, we are finding first E1. How to find the E1? E1. This is the distance k q by this distance square. This is the square. Diagonal is root 2a whole square. Right? This. Then comes to the E2. E2 q k q by this distance square a square. Number 2, and this for E3 will be the magnitude we are writing here, q by a square 3. So what we are observing, so here this E2, E3. Now what to do in this particular case? After finding E1, E2, E3, the resultant of E2 and E3, resultant of E2 and E3, we have to find out. Resultant of E2 and E3. Say E dash I am writing. So that parallelogram law of vector addition, E2 square plus E3 square plus 2 E2 E3 cos of the angle between them. The angle between E2 and E3 is your 90 degree. So cos 90 under root that is your E2 square plus E3 square. Cos 90 0. Now put the value and get it. Similarly, E3 E1 is E1 is already known. So what we are going to write it here. So net electric field is equal to E dash that plus E1. E dash क्या हुआ? ये दोनों का रिजल्टेंट E dash हुआ. E dash E2 स्क्वायर प्लस E3 स्क्वायर, और वो इसी डायरेक्शन में है रिजल्टेंट भी. So that's why E plus E1. So we are writing under root E2 square plus E3 square plus E1 is your KQ by under root 2A square. Right? That will be the your answer. And now put the value and get the answer. Very simple. Just a calculation part is left. Put the value E2 और E1 का क्या वैल्यू है, इसमें सेम वैल्यू है, यहाँ पुट कर दिए and ultimately you will get it. Right? And this is the way how to solve this particular question.